Hey, welcome. Ever stop to think about what really makes a new tattoo or piercing heal perfectly? Beyond just the artist's talent and you doing all the right aftercare. Turns out, there's this whole hidden layer of science that most people never even hear about. So today, we're going to dive deep into that invisible science, the stuff that actually determines whether your new body art will be amazing or not so much.
So let's just ask it outright. What is the secret sauce? What separates a piercing that heals like a dream from one that just turns into a total nightmare of irritation and problems? It's a question that gives a lot of people, and I mean a lot of people, anxiety. And honestly, for good reason. We all just cross our fingers and hope for the best, but it turns out science has a much better answer than just luck.
And yeah, the answer might actually surprise you. Aftercare is super important, don't get me wrong, but the most critical factor, that's often decided way before a needle ever even gets near your skin. It all comes down to the science of the materials, the metallurgy of the jewelry itself, and the actual physics of the tools being used. This is where the real battle for a happy, healthy piercing is actually won or lost.
Okay, let's start with the big one, metal myths. We hear terms like surgical steel all the time, and they sound super safe and official, right? Well, a lot of the time, these are just marketing buzzwords, and what they're hiding can be the real reason so many people run into problems. So let's put them side by side. On the one hand, you've got your so-called surgical steel. It's mostly iron and, here's the kicker, it has up to 14% nickel. Its ability to resist corrosion comes from this really fragile surface layer. But then you look at ASTM F136 titanium. It's a completely different beast. It's titanium-based, has virtually zero nickel, and its protective layer is incredibly stable. It can even heal itself if it gets scratched. It's a total game changer. So why is that nickel content such a big deal? Well, because almost 1 in 5 people on the planet has a sensitivity to it. But here is the most important part. Putting steel that contains nickel into a fresh, open wound can actually create a lifelong allergy even if you weren't sensitive to it before. Your body literally learns to see it as an enemy and attack it. That is a massive, massive risk.
And this quote from Patrick, a materials engineer, just nails it. He puts it perfectly. If you start with proper implant-grade titanium, you basically take the metal itself out of the healing equation. If a problem pops up later, you know it's not the jewelry. It simplifies everything and puts safety first right from the get-go.
All right, so we've settled on titanium being the best choice? Great. But hold on, because there's another level to this whole thing. The term implant grade gets thrown around, but it's not always what you think. We need to look even closer, because believe it or not all titanium is created equal, and not all of it is safe to put inside your body.
The real secret comes down to 3 little letters, ELI. That stands for extra low interstitials. Just think of interstitials as tiny, unwanted atoms, like oxygen or iron, that sneak into the gaps between the main titanium atoms. The more of these little invaders you have, the more brittle and the less friendly the metal is to your body.
Now, check out this chart. The difference in the amount of oxygen allowed between industrial titanium and proper implant-grade Eli titanium is just 0.07%. It looks like nothing, right? But that tiny, tiny difference is, and I'm quoting here, catastrophic at the microscopic level. That little bit of extra oxygen makes the metal way more likely to have microfractures, which are basically perfect little hideouts for bacteria.
And this table really breaks it all down. The right stuff, ASTM F136, has way stricter limits on oxygen and iron. For you, that means it's less brittle, it's less toxic, it's also more ductile, which is just a technical way of saying it can bend under stress without snapping. And maybe most importantly, that protective surface layer we talked about, it's self-healing. Every single one of these specs isn't just a number on a page, it's a feature specifically designed to make your piercing safer and healthier.
But look, even having the right recipe for the metal is only half the battle. How the jewelry is actually made is just as important. The manufacturing process itself can introduce all these hidden dangers, even on a piece that looks shiny and perfect on the outside.
So, most of the cheap jewelry out there is made by casting. You pour hot liquid metal into a mold. Simple enough. The problem is, this process traps tiny gas bubbles inside, creating something called porosity. These microscopic voids aren't just weak spots, they're literal hiding places for bacteria. A much better way is metal injection molding, or MIM, which fuses superfine metal powder together. This gets rid of those voids and makes a piece of jewelry that's incredibly solid and dense.
And for the absolute best quality, there's a process that's straight out of the aerospace industry. This quote says it all. It's talking about something called hot isostatic pressing, which is used on things like jet engine parts.
It takes the jewelry and subjects it to crazy high heat and pressure to squeeze out any final imperfections. I mean, if that's the standard for keeping a plane in the sky, shouldn't that be the minimum standard for something we're putting inside our own bodies?
So we've totally geeked out on the jewelry, but the science doesn't end there. We have to talk about the very first thing that touches you, the needle. It has its own hidden science, and its physical shape plays a huge part in how your body actually recovers from the get-go.
See, needles have different shapes, what we call tapers. A short taper needle is basically a blunter tool. It takes more force to get through the skin, which means more trauma and a bigger hole. A long taper needle, on the other hand, is engineered for minimal resistance. It just glides through the tissue, making a super clean, precise puncture with way less damage. Now, that difference in trauma has a direct effect on your biology. Your body has this very precise timeline it follows to heal any wound. But when a short taper needle is used, that excessive damage can send your body into a hyper-inflammatory response. It basically panics and overreacts, which can lead to longer healing times, more scarring, and for tattoos, it can even affect how well the pigment stays in.
So here's the bottom line. This is what it all comes down to. It's all connected. The right material, made with the highest standards, and put in with the right tool. Each of these steps is part of a system that's designed to work with your body's natural healing process, not fight against it. It's all about minimizing trauma from the metal all the way to the needle point. And that really just leaves us with one final big question. Now that you know about all this hidden science, are you asking the right questions? It doesn't matter if you're the client getting the work or the artist doing it. The standard for safety starts with demanding the right materials and the right tools, because your body deserves nothing less than aerospace-grade care. So make sure you're asking for it.